Hello, everybody. Welcome back. Uh, In this video, we're going to look at some examples of questions about normally distributed data. So from our last video, right, we found how to find a z-score and how to calculate the area under the curve of the standard normal distribution, right, which is the same area of the normal distribution that we start with, which in turn gives us the probability, right? The percent of our population under that curve and answers these questions for us. So we're revisiting this problem where we assume that commute times of students to school from home are normally distributed with a mean of 18 minutes and a standard deviation of 3 minutes. So if I draw this normal distribution, we've got a mean of 18 minutes at the center of our distribution. If I go 1 standard deviation to the right, I need to add 3 minutes, right? I need to add a standard deviation, so that would be 21. If I go 1 more standard deviation to the right, now I'm 2 standard deviations away from my mean. Add another 3 because that is my standard deviation, and I get 24. And lastly, I'll go 3 standard deviations away, add 3 more to get 27. Now as I go 1 standard deviation below my mean, I'll subtract 3 and get 15. If I go another standard deviation below that, subtract 3 from 15 and get 12. And lastly, I go 3 standard deviations below my mean, subtract 3 more from 12, and I'll get 9. So our first question asks, what percent of students take between 11 and 23 minutes to commute to school? So I find drawing these pictures can really help understand what the question is asking for specifically. So between 11 and 23 minutes, let's find that on our x-axis of our normal distribution, right? 11 is just under 12. So it's somewhere right in between here, closer to 12 than to 9. There's our 11, and 23 is going to be right here in between 21 and 24, but closer to 24, right? And we want to find this area in between 11 and 23. So what we first need to do is convert this normal distribution into a standard normal distribution. Specifically, we need to convert these values, the values of interest, into z values, right? So that we can find where they lie on the standard normal and use those z values to find the area under the curve for this shaded region. So I mentioned in the last video, when we've got these interval type questions, we actually need to convert, find 2 z values, right? We need to find a z value for this 11 and a z value for this 23. So let's do that first. So I'll just call this z1. We'll start with our 11. We'll take 11 and subtract it from our population mean, right? which is 18. And then we divide that by our population standard deviation, right, which is 3. So 11 minus 18 is -7, right? 11 is smaller than 18. And that negative is going to be very important for us. We divide that by 3, we'll get -2 point something. Yes, -2.33 repeating, right? It goes on forever. Remember to keep track of that negative. Now, if we find our second z value, we'll take our 23, right? Subtract that from our population mean, which is 18. Divide that by our population standard deviation of 3. Just remember, I'll rewrite it up here. Our z formula from our last class was z equals x minus mu. Mu is our population average or our population mean divided by our population standard deviation, right? Which we're given here. So you can see for each of our x's that we're interested in, we've taken each of those values, subtracted them from our population mean that we're given in our problem, 18, divided that difference by 3. So 23 minus 18 is 5, divided by 3, and we get 5 divided by 3 is positive 1.66 repeating, right? Okay, great. So now we've got 2 z values. Now what's our next step? We need to look up these z values on our z table, right? So if we go back a slide, let's find -2.33 first. This looks like our positive z table. Wonder, oh great, can move this. So we are looking for a negative number. Didn't show this in the last video, but we also have a kind of the same table, right? But for negative values. Let's see if I can move this as well. Okay, great. So let's try to find -2.33. What do we do first? We come here, we go down our z table first, and we need to find 2.3. So here's -2.3, right? And then we need to come over to 0.03, right? Because our value is -2.33 repeating. The 100th place is the farthest we can go using our table. So if we go down and across to where these things meet, we get 0.0099. So what does this tell us? This tells us that the area to the left of our 11, right, or our -2.33, that area this area under the curve is 0.0099. You might be thinking, well, that's not what we're looking for. How does that help us? And we'll see in just a minute. Let's look now for our 1.66. Okay. So let's go back, turn off, go back to my mouse. Let's go forward to our positive table. Let me erase this. Now we're looking for positive 1.66. So let's go down to, here's 1.6. And we're looking for 1.66, right? So we'll come all the way over to 0.06. Let's go down our table and across to where these two intersect at 0.9515. So now we found from 23 all the way to the left of that area under the curve is equal to 0.9515. Okay, great. So this blue area, if you can see that I've drawn with this line to the left, right, is from our 23 all the way to the left. And the blue area, let me see if I can undo that. So that blue line that I've drawn, that is equal to, what is it equal to in these terms of colors? Well, it's equal to the red shaded area, which remember is the shaded area we're looking for, plus it's also equal to this green area, right? You see how this blue line encompasses this red shaded area and this green shaded area? And now, look, we know what the blue shaded area is, and we know what the green shaded area is. We want to know what the red shaded area is. So if we know this and this, if we just take the whole thing, red plus green, if we subtract out green, kind of just like algebra, we subtract out green from both sides, this cancels out, we'll get some new value here, the difference, and we're left with red, right? Which is exactly what we want. So I'm gonna erase this formula. So let's just replace this kind of color-coded thing that I have here. These shapes with our actual values. So we know what we started with here, the blue arrow was 0.9515, and we don't know red, right? So we'll just leave that as our red squiggle that we're still looking for. That 0.915 is equal to the red unknown plus this green bit of 0.0099. So now if we just subtract 0.099, sorry, 0.0099, 0.0099, subtract that. This goes away, right? 0.099 minus 0.099 is just 0. So all we're left with, if we take this down a little bit farther, right? On this side of our equation is our red unknown, which is great. And if you just do 0.9515 minus 0.0099, I get 0.9416. Here, I'll try to rewrite that, make it a little more clear. Mouse disappeared on me. Okay, one more time. We get 0.9416, and that would be the area under the curve, which is exactly what we're looking for. So just again, the answer to this first question would be 0.9416, or you could write it 94.16%. So we'll take a break there. In the next video, we'll answer this next question. The probability that a randomly chosen student commutes between 17 and 23 minutes.